Last video I made this soft robotic gripper, and today I'm gonna design a 4-degree of freedom robotic arm for it. Well, that's a lie, I've already done that. But I'm gonna go back in time. I'm gonna pick the specific components and design a PCB which will link them together. Then I'm gonna order it, so I should be building the arm by the next video. Okay, let's do it. This video is sponsored by PCBWay. This is my shitty drawing of the robotic arm. It has 4 degrees of freedom because it has 4 motors. I'm gonna make the gripper interchangeable, so you will be able to choose a gripper with 3 fingers or a single finger gripper like this one. Let's ignore this motor for now. So the base rotates, these 2 motors rotate, and this is 3 degrees of freedom. This can move the end effector to any spatial position you want. So the spatial position is defined, but the rotation, you can't control that. So that's what this 4th motor is for. So I'm gonna tell the arm to move, let's say here, but I'm also gonna tell it the angle it should be at. So if I want to pick up, let's say a flask, I'm gonna tell it to move 90 degrees. And if I want to pick something up from the ground, I'm gonna change the angle to 0 degrees and pick it up. Okay, now that we have the rough idea, let's pick the main components. I got these spare servos from my hexapod. They are 40 kg and they might not have enough power, but I'm gonna work around that, which you'll see later. For the pump, I actually have a ton of them. I originally got them for my wall climbing suit, which I never finished. That's for the gripper. To control the arm, I have 2 options. I can either use an Arduino, which would be great because I have many of them and I don't plan on using them that much. Or I could choose ESP32, which would be also great because it has ESP now and I could control the arm remotely. So these are the main parts. I still have to choose a bunch of parts for the PCB and how I'm gonna wire them together. There's one more thing I wanna add. If you look at the size of this gripper, this arm is gonna have to be huge. Like, these 2 motors might not have enough torque, and that's why I'm gonna add a constant force spring. This spring should offset the torque of this motor. I wanted to try a few new things with this robotic arm, and this is the first one. At first, I'm gonna design the pneumatic circuit, because it's the more restrictive one. The main part is this pump, which is gonna be connected to the gripper with pneumatic tubing. I need to know when the gripper closes to stop the pumps. Otherwise, when the gripper is closed and I pump more air in, it's just gonna explode. So I'm gonna measure the pressure inside of this system. When the gripper is holding something and I want to release it, I somehow need to get rid of all the air. So I'm gonna use a solenoid valve that will just vent it to the atmosphere. Due to the pressure sensor being big as fuck, I'm gonna have to print some capsule to connect these components together. To connect the components to the tube, I'm gonna use pneumatic fittings, which I'm gonna label as stars. Now I have to pick the pressure sensor, the solenoid, the tube and the pneumatic fittings. I'm gonna do that right now to make sure everything works. For the pneumatics, I'm gonna need some tubing, so I picked this one because it's cheap. To connect the tubing to something, I'm gonna need pneumatic fittings. These fittings are great because you can press on the blue stuff and you can connect or disconnect the tube quickly. For the pressure sensor, I thought I was gonna find a bunch of these for cheap, but the only one I found that isn't expensive is this BMP180, and I can't use it because from the description it's only used for weather and stuff like that. The other one I found is this industrial pressure transducer. This is expensive, it's quite big, but it can read high pressures, which is what I need. So I'm using this one. Lastly, I picked the solenoid valve. I picked this one because it comes with these pneumatic fittings, which the tubing fits into. And it's also 12 volts, which is great. For the pressure sensor, I was able to find only a single pressure sensor, which is from USA, so it uses freedom units. I think it has 1/8 inch thread or something. And from what I can tell, there are no heatset inserts for this. But I found an adapter, which I'm gonna use as a heatset insert itself. So I'm gonna heat the fuck out of it, and I'm gonna press it hard as fuck into the hole. And if this doesn't provide a decent seal, I'm just gonna fill it with glue. Thank you, America. Alright, we got all the connections and all the components for the pneumatic circuit sorted, so we can move on to the electronics. Let's start with the power. The pump and the solenoid both need 12 volts, and the servo motors run on 5 to 7 volts, so I'm gonna use 7 volts. These are the two main voltages I need. So for the 12 volts, I'm gonna use a 3S LiPo battery, and I'm gonna step it down with a buck converter to 7 volts. Alright, so I got the battery. It's gonna run through a switch so I can power it on and off. It's gonna go through DC to DC buck converter, which reduces the 12 volts to 7 volts. And now I got the two main voltages I can work with. At first, I'm gonna power the Arduino with 7 volts. Then I'm gonna power the servo motors. And these servo motors are gonna communicate with the Arduino by 4 digital pins. Now for the pressure sensor, it's gonna take in 5 volts from the Arduino, and it's gonna output an analog signal which will tell the Arduino what pressure it's reading. Now for the pump and solenoid, these need to be powered by 12 volts, which the Arduino can provide, so I can't use the Arduino's digital pin. I have two options. I can either use a relay or I can use a transistor, and I'm gonna use the latter because it's more elegant. It's gonna output 0 or 12 volts depending on the value of the digital signal. So if the digital signal is on, it's gonna power the solenoid by 12 volts, and if it's off, it's just gonna be off. I'm gonna do the same thing for the pump. Oh, and I know this schematic is trash, but I don't have much time, and I'm gonna draw it properly in KiCad later. Alright, I got the pneumatics, I got the electronics, and now I somehow need to control the arm. I'm gonna use one joystick to control the X and Y movement, and I'm gonna have a second joystick that will control the height of the arm. And for the rotation of the gripper, I'm gonna use the second axis of the second joystick. These joysticks also have buttons. If you hold one button, it's gonna close the gripper, and if you press it twice, it's gonna open it. Or I'm gonna hook it up to the second joystick, I don't know yet, it doesn't matter. I'm also gonna add this potentiometer, which will control the pressure threshold of the gripper. So if I set it high, the gripper is gonna close hard. If I set it low, it's gonna close only slightly. So in total, that's 6 analog signals and 8 digital signals. The Arduino Nano has enough pins to support the analog and digital signals, so that's what I'm gonna use. The components have been chosen. The schematic has been drawn. Now I somehow need to take this schematic and plug it into my PC to then make a PCB which I'll be able to plug the components into. And then I'm gonna order it with my sponsor, PCBWay. PCBWay provides PCB assembly, CNC machining and 3D printing. They can even print stuff out of metal, so I'm definitely gonna try it out in the future. They also do other manufacturing stuff like sheet metal fabrication and injection molding, but I mainly use them for the PCBs. I usually try to design the PCBs to be under 100 by 100 millimeters, because then they only cost $5 for 10 pieces, which is really cheap. They currently have a Christmas and New Year sale, so you can get the stuff even cheaper. But before I order my PCBs, I'm gonna design them in KiCad. I wanna make 2 PCBs. One PCB is gonna be for the robotic arm itself, that's this one, and the second PCB is gonna be for the controller. So the controller is gonna have 2 joysticks, potentiometer, maybe some buttons, and it's gonna send signals to the main PCB of the robotic arm. It would be such that I could have the controller on the robotic arm and control it, or I could move it away and control it through a wire. This is the electrical schematic for the main PCB of the robotic arm. This is my second PCB I ever made, so if there are any electrical engineers watching this, definitely let me know some tips. I'm just gonna go through each component super quickly, just so you can see what I'm gonna have on this PCB. The first thing is power input. Here you input the 3S LiPo battery, ground and voltage. It goes through a switch. When you turn the switch on, it powers the buck converter, which steps down to 12 volts to 7 volts. The 7 volts then powers the servo motors, which are down here. It also delivers power to the 12 volts power line, which makes this LED shine. This will be the indicator for the power. Next I have this pressure sensor. The pressure sensor works like a variable resistor. You input the ground and 5 volt pins from the Arduino, and based on the pressure it outputs an analog signal. This is read by the Arduino A7 pin. Already went through the pump. The solenoid looks the same as the pump, and it's controlled by the D9 pin. I also added some redundant power pins. One of the most important things is the controller output. This is the output from the second PCB, which I'm gonna show you in a second. And these are all the controls. These are the joysticks, the potentiometer, and the buttons. This is again all read by the Arduino. I also added these redundant general purpose input-output pins. These are the analog and digital pins I haven't used. I've just put them to this pin header. So in case I need them, I can use them. And that's it. Now I'm going to show you the second schematic for the second PCB, and then we will move on. This is even simpler than the robotic arm schematic. This is optional. It's just in case I used ESP and I wanted to make this wireless. I'm probably not going to do that, so I'm just going to ignore it for now. This is the output of this controller, but it's also input for the power. There's going to be two cables which take in power from the robotic arm and transfer it to this PCB. Again, I have an indicator light, which will tell me if it's on or off. Then I have two joysticks. These will control the 4 degrees of freedom. The joystick also have two buttons, and I've put potentiometer and two additional buttons. So I have some redundancy and I can use more controls if I want to. So that's the schematic. If you want to see the whole process of making these PCBs, I'm gonna upload a video on my second channel where I explain the circuit in detail, assign the footprints, and make the actual PCBs. Okay, now I'm gonna order the PCBs. So the dimensions are 100 by 100 millimeters. It's a 2-layer PCB and I want 5 of them. I'm gonna choose the black color because it looks cool. Now I'm just gonna upload the Gerbil and drill files. They're gonna make the PCB and then ship it. These are all the things I bought from AliExpress. I also added some springs and I'm gonna try to make the arm out of carbon fiber tubes, so that should be interesting. Until the parts arrive, I'm gonna upgrade the gripper and I'll see you then.